This is group B, and we're going to make a presentation about task 4, and this is the index. First of all, I'm going to describe problem, and the second, I'm going to talk about how to solve using first equilibrium, deformation condition, and calculation. And the final part will be results. So let's describe this problem first. So both sides, left and right, are fixed. Their shafts number n from 1 to number n, and given values are as follows: torque T1, 2, T2, 3 to Tn minus 1, n, and polar moment are from I1 to In. Shear modulus are G1 to Gn, shaft length L1 to Ln. And finally, shaft radius will be R1 to Rn, and we have to find values, total angle deformation from the left side, pi1, pi2, and pi n minus 1. And we gotta also find shear stress, tau1, tau2, tau n, and internal torque, T1, T2 to Tn. And let's move on to the how to solve. We gotta use torque equilibrium along x-axis. First of all, we gotta put reaction torque. The left side will be R1, and to the right side will be R2. The total torque should be 0. So T1, 2 plus T2, 3 plus 2Tn minus 1, n minus R1 minus R2 should be 0. And each shaft has internal torque, Tk. We're going to define this Tk as follows. So T1 will be R1, T2 will be R1 minus T1, 2, and etc. Tk will be R1 minus T1, 2 to minus Tk minus 1, k. And let's move on to deformation condition. We're going to define theta k as follows. Because pi k is the total angle deformation from the left side. There's a relationship between theta k and pi k as follows. So we know the theta n, so we can calculate pi n. As both sides are fixed, pi1, pi 0, and pi k are 0, so the summation of theta 1 to theta n will be 0 by deformation condition. So here we have two equations, and there are two unknowns, R1 and R2. So we can solve these equations. This is the process how we found out R1 and R2. We defined In over Gn, Ln over Gn times In as Xn to simplify the calculation, and we found out R1 and R2. And the values that we are finding are as follows. Internal torque, T1 is R1, T2 is R1 minus T1, 2, and etc. Tn will be like this. Also, we can find maximum shear stress by this equation. Tau k is internal torque times shaft radius over polar moment of the shaft. And lastly, the pi1 will be theta 1, and pi2 will be theta 1 plus theta 2, and pi n will be the summation of the zeta 1 to zeta n. So we found the values, and I'm going to cover the results. I'm going to open an Excel file. So on the left side, there are input values, and in the middle, output values. And on the right side, there are values that we defined. T1, this should be T1, 2 torque. So we simplify the n shafts into 3 shafts. So there's 2 torque. This is not internal torque, and there are 3 per modulus, and there are 3 shaft lengths. There are 3 polar moment of the shaft and 3 radius of the shaft. So here we just change the first torque, the torque between the shaft number 1 and 2. We set the other values as the same as follows. So we can find out the maximum shear stress tau 1 and tau 2 change like this. And the angle deformation pi 1 and 2 like this. X1 to 3 is the X1 is the value ln over gn times in, and R1, R2 will be the reaction torque on the left side and the right side. Okay, this is the end of the task 4 presentation, and thank you for listening.